In this video, I intend to explain the difference between population versus samples when it comes to statistics. First, we must go over the vocabulary. The first vocabulary word is variable. A variable is a characteristic of a person or thing which can be classified, counted, ordered, or measured. Next vocabulary word, population. A population is all the individuals that we're studying. And last vocabulary word is sample. A sample is a subset or part of the bigger population. Example 2. A study is to be conducted on the psychological effects of personally witnessing a jewelry store theft from a local mall. Police records suggest that there were a total of 23 witnesses. Is this a situation that would suggest that the entire population be included in the study? Why or why not? Because there's many different types of people that go to the mall, such as older people, younger people, teenagers, people that like different types of music, people that shop for different things such as technology or music or clothing. This population size is a little bit small to get a good representation. So yes, this does warrant the entire population because the population size is too small to represent the various types of people that go to the mall. Example 2. A new medicine has been developed that the developer claims will stimulate hair growth in bald men. Would you expect there to be safety tests conducted on the population of men before release? Simple answer is there's many bald men in the world, so it'll be impossible to test this on every single bald man. So no, there are two. The reason being, there's too many bald men in the world, so a sample size would be more sufficient for this study. Example 3. The Ford Explorer is a popular sports utility vehicle sold in the United States, originally equipped with Firestone tires. In May of 2000, Ford and Firestone were both accused of responsibility in hundreds of vehicle accidents caused by tire failure. Given that all vehicles sold in the U.S. undergo extensive safety testing, how could so many bad products have slipped through? So there's many different possibilities that could have happened. One possibility could be that the whole population of Ford Explorers was not tested. If the whole population is not tested, that could explain why some of the tires that came out were bad, causing hundreds of accidents. Another possibility, only vehicles with good tires were tested. And that makes sense because if the whole population wasn't tested, then there'll be, if only the good tires were tested, then there could be some that slipped out of the factory with bad tires. And the last possibility that we could have is the test was bad. There's other possibilities, but these are three that jump out. Example 4. You and your team are conducting a study on the differences in the ability of students in your school to focus different during different times throughout the day. Each day, your team chooses every third student to walk in the door, and you study 112 students on Monday, 78 on Tuesday, and 109 on Wednesday. If there are 299 students in the school, is this a sample or a population? This will be a sample because we are only testing every third student, not the whole population. So this would have to be a sample. If we tested every student that came through the door, then this would be a population, but that's not the case in this problem. Example 5. Why would it be virtually unarguable to state that a product claiming to be everyone's favorite soda has not been properly evaluated from a statistical standpoint? Reason being, it is impossible to find out every single person in the world's favorite soda. So the reason being, it is hard to study every person in the world. That's why it is not possible to evaluate this from a statistical standpoint. Number 6. A biologist captures 96 trout from different parts of a lake to determine the age distribution. She finds that 53 are less than 6 months old and 29 are between 6 months and 1 year old. What variable or variables are being studied? The variables being studied are the age of the trout. Part B. Is this study based on a sample or a population? If a sample, what is the population? What steps are being taken to make the sample representative? This is a sample because not every fish in this lake is being pulled. And there could be more fish in this lake. The population would be all the trout in this lake. So we know there's probably more than 96 trout in a lake. And there's many different places fish could hide. So we're going to assume that this is a sample, not a population. In part C, what percent of the trout are less than 6 months old, between 6 months and a year old, and more than 1 year old? So let's start with less than 1 year old. Sorry, between less than 6 months old. So we know there's 96 trout in the lake, and there are 53 less than 6 months old. So we divide 53 and 96, and we get 0.502. So that'll be 0.552. That'll be 55.2%. We do a similar procedure for between 6 months and a year old. So again, we know there's 96 fish total in this sample. And we take a look and see that there are 29 between 6 months and a year. We divide 29 divided by 96. And that should give us 0.3 302 or 30.2%. And then last but not least, more than 1 year old. The problem doesn't tell us, so what we need to do is take the total number of fish, total number of trout in the lake and subtract. So we'll take 96, subtract 53, and subtract 29 to find that total. So when we take 96 minus 53 minus 29, we end up with 14. Then the last step will be just do 14 out of 96 and divide, just like in the previous two parts. And we get 14.146 or 14.6%.